Well, hello everyone. Thank you for joining us today. My name is Yasmina Greco. I'm with O'Reilly Media, and I will be your host for today's webcast. Today, folks, we have Simon Monk presenting Getting Started with .NET Gadgeteer. Simon is the author of several best-selling books, and his latest book is the new O'Reilly Media Make book, Getting Started with .NET Gadgeteer. We are so excited to have Simon with us today to present this webcast for you all. I'll turn the program over to Simon in just a moment, but first I'd like to go over some housekeeping things to help you get the most out of today's webcast. You'll want to open the group chat widget if you haven't already done so. This is where we can interact with each other during the event and where you can submit your questions for Simon. We find that our audience usually has a lot of good knowledge to share, so we encourage you all to chat freely during the event. However, if you have questions for Simon, please preface them with a capital letter Q so we know that they're for him and we can make sure he sees them for Q&A. You can also open, move, and resize any of the other widgets. If you'd like to tweet from the Twitter widget today, you may need to give it permission to access your account. The Twitter widget will automatically append the event's hashtag to your tweet so you don't have to. And our hashtag today is Gadgeteer, all one word. If you should have any problems during the event, please take a look at the Help widget. If you continue to have problems, please post it in the chat room and one of our staff will help you right away. For choppy audio or stalled visuals, please try refreshing your window. And remember, the best thing you can do for a good audio stream is close any apps that could interfere. People always ask, so we'd like you to know we are recording today's webcast and we'll have an archive ready usually within 48 hours. And folks, at this time it is my pleasure to turn the program over to Simon for his presentation. Hello, Simon.
Hello, Yasmina, and thank you very much for the introduction. And thanks to everyone for coming along for this webcast about .NET Gadgeteer. My name is Simon Monk, and I've been writing books for a little while now, mostly on the topic of open source hardware of various different types and electronics, including Arduino, Raspberry Pi, IOIO, and also .NET Gadgeteer. You can find out more about my books on www.simonmonk.org. That's the end of the advert. Okay, what I'd like to talk about today is first of all look at what exactly .NET Gadgeteer is, what kind of things you can make with it, who's the intended audience for this product, how does it compare with things like Arduino, where does it sort of sit in the market, hardware options, different types of Gadgeteer hardware that you can get hold of, how you use the software, and then I'm going to look at a few examples using the .NET Gadgeteer and end up with a few resources to get you started and different places you can go to look for more information about .NET Gadgeteer. So .NET Gadgeteer is essentially a kit for electronic construction. And somebody once described it to me as essentially a smartphone that's been broken apart into little bits and then had cables attached between them. So it's plug and play. There is no soldering. This is, I suppose, one of the distinguishing features from something like Arduino. It's very much the case that you just plug things together with these little cables. You program it in C# using Visual Studio. For people who are used to using Microsoft tools, then this is great because you've already got the skill set. You're used to programming in C#, you're familiar with Visual Studio, and it's all pretty straightforward. It's a product that's come out of Microsoft Research as well, .NET Gadgeteer. So let's have a look at some of the kind of projects that you can make with Gadgeteer. You can, for example, make a simple digital camera, a not very high resolution digital camera, but nevertheless a digital camera. So you would start with a main board, which you can sort of see immediately above the screen on this slide. And then above that, you can make out a camera module. And then to the left of the main board, you've got an SD card holder so that you can fit an SD card in so that when you take the photograph it can save the image. And then you have the screen itself where you can see previews of a picture you've taken, and it's a touch screen as well, so you could have, instead of having a physical shutter release button, which you could also do, you could use the touch screen to take photographs. You can make little games with it, and what you can see here is a joystick and the screen connected to the Gadgeteer. And quite a few people have gone, taken the nice idea of building a sort of retro games console, building a little miniature retro games console with a joystick in it and a few big red buttons that reminiscent of the sort of 1990s style arcade games. Other things you can do with it? Well, you can make use of various different types of communication mechanism. There are expansion modules that allow you to connect your Gadgeteer to the Ethernet and then obviously out to the Internet and the World Wide Web. You can get Wi-Fi modules that you can plug into it so that you can do the same thing but do it without wires. There are Bluetooth modules so that you can connect to your phone. There's also even a cellular modem module, complete with little antenna. So you could actually build yourself a little mobile phone. Well, I say little, I don't think it would be terribly little, but you could make yourself a mobile phone with Gadgeteer components. Another area that you can look at is storage. You can, as we sort of touched upon with the camera, you've got an SD module that you can plug an SD card into, but you can also get a USB host module. That means you can plug USB storage into the device, and various options for interesting kinds of projects you can make that store data or log data from sensors, that kind of thing. So if we're comparing these two technologies, the Gadgeteer versus the Arduino, well, the Gadgeteer has a lot more performance, simply in terms of raw hardware performance anyway. It's clocked at hundreds of megahertz, whereas the Arduino is clocked at sort of 16 megahertz typically. There is lots of memory on the Gadgeteer. On the Arduino, you just have a couple of K, and you have to write your code very carefully in a sort of C-embedded programming style to get things to fit on there. Whereas with the Gadgeteer, you can, if you're used to the big programming paradigm, making yourself classes and all those sort of big patterns and big way of programming, lots of dynamic memory allocation things, you don't have to learn a new way of programming to be able to use it as an embedded device. You can use exactly the same tools and exactly the same language, C# as you would if you were writing a huge, great web application. So also, like we're saying, it's rather like it is like a smartphone in bits. The kind of bits that it's in are actually rather at a higher level than the kind of bits that you generally use with something like an Arduino. An Arduino being more of a controller, so you might use it to control an Arduino to control relays and fairly low-level, real-time type situations, whereas the Gadgeteer is kind of more, I suppose as the name implies, more to do with gadgets, build your own gadget. The Gadgeteer, relying of course on Microsoft technologies, is Windows only, although obviously people do, myself included, run that Windows in a virtualized environment. You don't necessarily have to have your entire environment as Windows, whereas Arduino is cross-platform. So I suppose if you were to compare the Gadgeteer to a car, it's more like a sort of good, solid car, a sort of Ford Escort or something. It's ready-made, it works, it does the job. There's a minimal amount of fuss to do with getting things working on it. Whereas an Arduino is perhaps a little bit more, I would argue, like a kit car. It's cheaper, it's sort of kind of lower level. It requires some finishing by the user rather than being kind of a sort of much more ready-to-go system. It's one of those conundrums when you start with a Gadgeteer with a basic set of starter components, and you maybe only got a few modules that come with the starter kit, and you look at them and you think, well, what can I actually make? I can make sort of 4 different things. It's sort of, in a way, how many different variations are there that I can plug things together to make something with a Gadgeteer? But of course, when you go out and look at the huge range of modules that are available at quite low cost from other manufacturers, from all sorts of manufacturers, that's where you start to realize the options and the different types of things that you can make with Gadgeteer. Yeah, so as I was saying, higher level of abstraction really, higher level types of component that you would plug onto the Gadgeteer. Smartphone type systems rather than robots and real type control type systems, which tends to be the staple of the Arduino. I think personally that the Gadgeteer is an excellent tool for education. There's no soldering irons, so there's no burnt fingers in a classroom setting. It's generally quite quite easy to use like that. Okay. And I think as well, people who are software people, who are used to writing software but perhaps not that familiar with hardware and electronics, then a lot of the electronics is taken care of for you. You kind of don't worry too much about the electronics. You just see the electronics as a library that you use in the software. Okay, so who is the Gadgeteer for? As I say, I think largely for, it has a good role to play in education. I think it has a good role for people who don't necessarily want to get involved in soldering. I think it has a role for inventors and designers who know what they want to build, but don't necessarily, again, want to get into the low-level electronics. They want to be able to plug things together in a fairly straightforward manner. And of course, software people who, again, for the same sort of reasons, are not necessarily that au fait with electronics, but know what they want to make and know how to write software. And this gives them a vehicle to do that. So, the link with Microsoft is all on the software side. They don't actually make Gadgeteer hardware. And there are various manufacturers of Mainboards, and I'm sure this list is probably out of date, and I suspect I'll probably miss some people out. But as always, Google is your friend. If you search around, you will find lots of people who are making Mainboards for the Gadgeteer. And the Mainboard, I probably should have pointed out, is the board that sits at the center to which all the other modules are then attached. Okay, and the main manufacturers of these Mainboards are GHI Electronics, Mountaineer, and Cytec. The modules you can get, you can almost do an A to Z of different modules. There's so many different ones. And if we start with sort of things like, with the A's, I suppose, there's accelerometers, barometers, Bluetooth modules, just even simple buttons so that you can attach these to a panel and have push buttons and LEDs and things like that. A camera, a CAN interface for getting data off vehicles. A cellular radio, so you can build things with a GSM, GPRS modem, so data logging out in the field using an appliance that's built with this. Modules, other modules, let's have a look. We've got a compass, so again you could build yourself some kind of tracking device or some mobile navigation device. Current measurement for smart meters, energy monitors. We have the touchscreen display. We have GPS module for, so that you can do global positioning. Gyroscope, joysticks, LED, multicolor LEDs and single color LEDs, and LEDs in a circle that you can flash around in a nice pattern, all sorts of things. Light sensors, moisture sensors, motor drivers. So you can put a Gadgeteer in place to build a little robot, and I'm sure again in an educational setting that would probably be quite a fun thing to do. MP3 music playing, OLED displays, potentiometers, even a pulse oximeter, which is a device for measuring your heart's rate, controlling relays, SD cards. Okay, so how do all these different types of component that probably all have quite different sort of interface requirements work off a single type of socket? And they all do connect through these little 10-pin sockets, but the sockets come in a number of different types indicated by the letters next to them. So some of them have got analog inputs, some of them are very specific, and they just act as one channel for, say, the red on one of the displays. Some of them are USB related, some of them are specifically for connecting Ethernet, and other ones are to do with various different types of serial ports, I2C, SPI, and UART serials, and others are just digital input-output pins. You can also get general purpose boards that allow you to just add your own electronics onto the, to the Gadgeteer, so that if you are happy building your own electronic circuits, then you can take that step as well. Although personally I would probably argue that if you were going down that route, then you might probably be using a different technology anyway. Software, Visual Studio, as I mentioned before, you don't have to have a commercial license for Visual Studio. You can use Visual Studio Express, the free version. It's C# is the language that you'd use, which is Microsoft's Java-like language. And you use exactly the same IDE and language as you would for big software. Again, this is part of the appeal, I think, for people who are used to that technology. The other thing that you get, which is really nice, is a visual hardware designer. And so the side effect of the fact that you have so many different socket types and things is that you need to be careful that you don't connect a module to the wrong type of socket. And you actually get support within Visual Studio to tell you which sockets you should be connecting a module to. So you design it on a canvas and then connect it together. So here's an example of that. At the bottom we've got a main board, and then we've got an LED module and a button module. And this is kind of a really simple example. It's almost a massively over-engineered switch to turn a light on and off. But it's almost kind of the Hello World example, I think, of the Gadgeteer, a bit like Blink in Arduino. So we have the main board at the bottom, and then we have an LED module up and to the right, and a button module over to the left and up. And if we started to drag a line, we assume these connections weren't there, and we started to drag a line from the button towards the main board, then on the main board, the sockets that were compatible with that button would turn green, and you could join the button to an appropriate socket. And it simply wouldn't let you join it to one that wasn't compatible with it. So you take this step first, and you, if you like, draw your hardware, and then you go to the real device, and you start plugging the things together as per the diagram, which is a nice way of working. And obviously what's going on in the background is that it's generating code for you, for the actual glue part that's sticking all the different modules and the main board together. So this is what the actual hardware looks like. So in the center we've got the main board again, and then we've got the LED at the top of the right, top at the right, and the switch on the right at the bottom. This other red board, which is over to the left, is actually serves two roles. It firstly acts as a USB connection to your computer. So you connect your computer to that USB lead on the far left, and you use this red board to program the Gadgeteer board directly from Visual Studio. It also supplies power to the Gadgeteer board, and you can see just below the USB socket there's also a barrel jack socket, so that you can plug it into a DC adapter and supply it with, I think, probably something like 8 to 12 volts as a guess. Okay, so the code, you can see at the top of this screen there's actually two tabs, and the tab on the left is what we would see if you with the previous screens, where you've got the visual designer that lets you drag the components around, and the tab that's currently selected, this tab, is actually the code view of the, if you like, the code that has to cope with what happens when you press a button and all those sort of things. So you can we'll go through this in a little bit more detail, but you can see there's basically a sort of programming running function that gets called. So the programming is C#. It's object-oriented, so you're using classes and methods And you also very heavily use events and handlers in the .NET Gadgeteer. So if we look at the main method called program started, which will automatically get run when the device first starts, you'll see what we have here is it says button, and that refers to, if you like, the software proxy for the actual physical button that you've connected together. So we say button dot button pressed plus equals, and then we've got a new button dot button event handler. And what that is doing is adding a button event handler to the button pressed event. Okay, so it's associating the two together. And where we've got the parameter that we've got to the button event handler is button underscore button pressed. And that is the name of a method that will get called every time the button is actually pressed. Okay. You get a great deal of command completion as well with Visual Studio. So as soon as you start typing something, you only need a few letters before you can control space or tab it on to complete the code for you. And in fact, it will also generate the event handler methods for you too. It will generate stubs for them, and then you just fill it in with your own handler code. Okay, so here's an example of that handler, button underscore button pressed, and a few parameters get passed into it automatically. The sender, which will be a button, and also the button state, so whether it was depressed or raised, as it were. And the handler code, all we do here is we then use the proxy for the LED object to get the current color, and if the current color is black, which means the LED is off, then we turn the LED red, otherwise we turn the LED off. So all that's going to happen with that little push button is it will toggle the LED on and off. Let's have a look at another example. This one is for an SD card backup. So the idea is that you take photographs with your digital camera and you're on holiday or something, so you may not have your laptop to hand, and you want to be able to back up the photographs that you've taken onto a USB data drive, data stick. So there are two storage interfaces connected to the main board. The one on the left is for an SD card, and the one hanging off the right of it is a USB host socket. And also hanging off the main board are two LED modules. You can see that one is kind of lit well, I'm not sure it's lit at all actually, but the one on the right is red. And only one of these LED modules is actually connected directly to the Gadgeteer main board. The other one is daisy-chained off the first one. So you can actually create strings of these multicolour LEDs all joined up. Another thing to point out about the modules on the main board is that they've also got mounting holes in them, so that you can laser cut, and people have created 3D models of all these modules and the main boards and things. So you can actually laser cut pieces of acrylic and fix them to the back of them and create all sorts of nice enclosures for your projects, because the geometry of these mounting holes is published and part of the definition of that particular module. I should say actually that the way this operates, there we are. The way this particular project operates is that you put an SD card into the SD slot, and then the LED that's associated with the SD card would go green to show everything's okay. And then when you do the same thing with your pen drive and put it into the USB slot, then once that goes green, it automatically starts the transfer of all the files that are on the SD card onto the pen drive. That's kind of the requirements for this particular project. So this is the hardware diagram, and again, as you can see, we just as we're connecting up modules, it'll only let us make valid connections to the main board. And there's a sort of palette on the left-hand side where you can pull out all sorts of different types of main board and all the different types of module. So when people go about designing modules for use in the Gadgeteer system, they, as well as producing the hardware for the module. They also produce a software component that gets added to Visual Studio so that you can then pick those devices off the palettes and use them with the visual designer. So the software for this one, again, we've got our program started method that gets called automatically, and you'll see that it's basically just a long list of event handlers getting associated with things. So there's an event handler for the USB drive being connected and being disconnected, and as these things happen, we'll just sort of change the color of LEDs, and that's essentially how the workflow of the application is managed, just by these events getting called as these events occurring and calling the appropriate handlers as the project is used. So, for example, if we look at the handler for when the SD card is mounted, it turns the LED green. It then sets a global variable to keep a handle on the storage device of that SD card, because one of the side effects of this kind of event-based programming is that the next thing that happens is another event somewhere completely different will probably get invoked that uses that will also need to know the storage location of the first SD card. So maintaining state between these various event handlers does sometimes require you to put something up at a class level that they can both access. So the code for these examples that I've shown you and all the other projects in my Gadgeteer book is open source, and it's freely available. So even if you're not interested in the book, you can go to www.gadgeteerbook.com and download the software and just have a play. Okay, one more little example for you. This one is a web messenger, and this is probably my favorite project actually that I've built with the Gadgeteer. And I'm going to show you a sort of short video in a moment illustrating how it works. But the basic idea is that you have the Gadgeteer mainboard acting as a web server. So that's an Ethernet connection up in the center of the picture. And you have a little multicolor LED that shows the status of that web connection, whether you're connected or right. And then you have the touch screen with a little palette of colors on the left-hand side. And you can draw a little smiley face on there or whatever you like. And if you've opened up the right ports and your Gadgeteer is accessible to the internet, then people can see what you've been drawing on there, which I think is quite a nice little project. So I'm going to ask you to, we've actually got I've got a video of this on YouTube. We don't have a way actually of integrating the videos directly into the presentation. So what I'm actually going to do is push a URL for the video out to you. And what I'd like you to do, the video does have a commentary. So what I'd like you to do is press the play button as soon as you can after I've pushed it out to you, and then we'll rendezvous back in a minute or so when the video is complete. Right, I'm going to push that out to you now if everybody's ready. Okay, here we go.
So on the left of the screen we've got a browser, and just behind that you can see Visual Studio, and on the right of the screen we've got a Fez Spider mainboard with a screen and a few other components connected to it. So here we are, we've plugged it in, and you can just see it booting up there, and the LEDs come on, and at the moment the LED is red. There's some status code that tests the Ethernet connection. So the trace at the bottom there is it all starting up, and okay, so the lights are. I'm just plugging in the Ethernet connector there to the mainboard, and you can see the application with the color palette on the left hand side on the screen. Okay, and then we've got a message saying web server started, and then an IP address. So what we can do now is go back to the browser, go to that IP address and enter it into the address bar at the top. And we're not going to put any action on the end of here. What this will actually do is open up the default action which just lets us know that the web server is up and running. So what we can do now is add an action to the end of the add a page, to the end of the address bar, which is sketch. When that refreshes, we see we've got a black screen. Okay, so what we're going to do now is pick a colour. So have yellow, and then let's just do a bit of drawing on the screen. Refresh rate isn't great on that, and then I think we'll underline it in red. And then we get back to the browser and click on the refresh button, and there we go.
Okay, well, my playing of the video has come to an end, so I'm just going to kind of assume that everybody else's has. So let's press on. So really, just to sum up, some of the resources for hardware, if you look at the GHI site, ghielectronics.com, you'll find a lot of useful resources there, and these are one of the main drivers behind the .NET Gadgeteer movement. Seed Studio also have a lot of modules for sale, and a lot of very low-cost modules as well, and some really quite impressive, technically impressive modules too. Mountaineering.org has some Mainboards and other Gadgeteer-related stuff. SciTech also, and DF Robots are also worth looking at for Gadgeteer resources. For software, the most active kind of bulletin and forum for Gadgeteer people is the TinyCLR website and the related forum that's associated with that. It's also where to go for instructions on installing, and TinyCLR, there is lots of information on there that's very useful. The more official sites, if you look at the netmicroframework.com Microsoft-related site, which has a lot of Gadgeteer information on, and also the Gadgeteer Codeplex is a useful resource. Books. I think I might have mentioned my book. I'll just mention it again. There is another book as well that's very recently out, the Microsoft.NET Gadgeteer Electronics Projects for Hobbyists and Inventors, by another Simon. It seems that you had to be called Simon to write about .NET Gadgeteer. Okay, so just to summarize, Gadgeteer offers you a way of doing solder-free construction. You have a huge range of hardware modules that you can plug together, and a lot of these modules are quite sophisticated modules. They're quite they're the kind of thing that you'd find in a smartphone. There's a range of different sizes of mainboard with different powers, so you can get more powerful processors, less powerful processors, mainboards that take up less space but have fewer sockets, mainboards that are quite big and have a load of sockets on them. So you can kind of tailor, you can choose a mainboard that suits your particular requirements. It's very accessible to Microsoft programmers, and I think it's an excellent education tool. I saw a very good demonstration, it's actually a teaching session done by some folk from Microsoft who brought a whole load of laptops and some Gadgeteers and plonked them in front of a load of school kids who made I think they actually made a camera, which was quite impressive. You could see that they were enjoying plugging this stuff together. Okay, that's the end of the spoken part of my presentation, and I think now, Yasmina, we turn it over to questions. Is that right? Okay. When you string the same modules together, do you access them by unique ID or the like? Let's say you add a number of LEDs on, by default, as you plonk them onto the canvas, it'll call them LED 1, LED 2, LED 3. But you can also go to the LEDs on the visual editor and actually change the name to something that's more meaningful to you. So, for example, on something like the SD card backup, I would call one of them SD status LED and the other one USB status LED, for example. Right. Another one from Morgans Nielsen. Can we get a list of the best places to buy these components, selection stroke price in mind? I think it changes so quickly that there's not really any one place that I could kind of recommend that you go to look for components. But I think certainly if you look at the GHI website and you look at the Seed Studio website, you'll find a very good selection there. Suresh, is it possible to do some home automation stuff with the Gadgeteer? Yeah, I think that's an excellent question. I think it'd be a very good vehicle for home automation. As well as the wireless modules, which obviously help a lot with this kind of thing. There are sensor modules. Seed Studio have quite a big range of different types of sensor module and also relay modules. So you can, with the relay module, you can control quite high power devices and have the Gadgeteer switch relays on and off, and which would in turn turn, mains powered lighting on and off, that kind of thing. Okay, any more?
And with that, Simon, we do have a question from Brett. Brett asks, what is your favorite module you have?
Okay, I think it's the pulse oximeter, actually. I think you have a lot of fun with that. It's I made a little, just to sort of test it out, but a little thing with a little circle of LEDs that pulse around in a loop every time it detects a pulse. It's a good way of checking that I haven't actually died.
On behalf of O'Reilly Media, we would like to say a very big thank you to you, sir, for presenting a really fabulous and fun webcast for us all today.
Oh, you're welcome. No, I enjoyed it.
And folks that attended, we hope you benefited from today's webcast and enjoyed it as well. We'd like to remind you all, please take a look at O'Reilly.com/webcast for all of our events coming up. They're all free. Spend an hour with us, learn something, have some fun, and make it a worthwhile experience. Again, thank you, Simon. Thank you, everyone. This will conclude today's webcast. Goodbye, everybody.